All right, in this lesson, we are graphing tangent and cotangent part 2, so a little bit more complicated. We're going to start by graphing a cotangent graph. So this cotangent graph is going to kind of have a downward trend to it. The period's going to initially be pi, may be messed with. So first thing is, let's rewrite this. So because we need whatever is attached to the x, we need to factor it off. And that'll give us a better idea what our phase shift is and how our period is being messed with. So if we factor a 2 out, that's going to leave us with a 3 pi over 8. Okay, so again, we're kind of cheating this language a little bit. Technically, describing it as an amplitude is not correct on a tangent and cotangent, but this way it keeps it really consistent with what we're already familiar with our sines and cosines. So we're going to have a vertical stretch, aka an amplitude, of 3. The period is going to be divided by 2. So tangent, typically cotangent, your period is pi, and we're going to divide it by 2. Your phase shift is going to be right 3 pi over 8. And then our midline, we don't have anything. That would have been plus or minus kind of at the end here. All right, so we're going to kind of anticipate a little bit that our graph's going to be stretched up and down, and we're going to shift it right 3 pi over 8. I don't know exactly how far that's going to be, so I'm going to give myself some space to the right. For cotangent, we're going to go from asymptote to asymptote, starting at the origin. So we're going to plot 1, 2, 3, 4 spots to the right. So 1, 2, 3, 4. Our period is pi over 2. So that is going to be pi over 2. And then we'll cut it in half, which will be pi over 4. Cut it in half, pi over 8. So that's 1/8, 2/8, 3/8. Okay, so cotangent, this normally would be asymptote to asymptote. However, everything is going to be shifted to the right 3 pi over 8. And let me put in my 3 spots for our vertical stretch. Okay, so we should be asymptote, but we're going to shift it right 3 pi over 8. So that asymptote is going to shift to right there. Okay, and then we're going to go 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. I don't even know if that need to go that far or not. But this is 5/8, 6/8, simplifies to 3 pi over 4. Okay, so we have asymptote. We would have had, our other asymptote would have been at this spot, because that's how big our period is. So we're going to go 1, 2, 3. And that's where that new asymptote is. So that is still our pi over 2. We took the asymptote that should have been here, we moved it 1, 2, 3 to the right. We took the asymptote that should have been here to finish off the period and moved it 1, 2, 3 to the right. And then this really kind of lines up the rest of our graph. So this point in the middle is still this point in the middle. And then we vertically stretched it. So we are looking at cotangent, so our points look like this. And then we hug the asymptotes. All right, so that is our cotangent graph. And then we're going to do one more. That is back to a tangent. So it's going to be going up, and we're going to have asymptote on the right side and asymptote on the left side. So we're going to center it around the origin as opposed to kind of starting at the origin and moving out. So same stuff. Let's rewrite this thing. So we have a 2, tangent, we factor off the 2, and then that's going to be, because we're factoring it, we're dividing it off, and so that is our new equation. Our amplitude is 2, so we're going to vertically stretch it by a factor of 2. Our period is pi divided by 2, so same thing as the other one. Our phase shift is going to be right pi over 2, and then our midline, we don't have anything. Now strangely, you're going to shift right pi over 2, so we're going to see that that ends up being a little bit weird. Not weird, but there's something unique on it. So we're going to give ourselves some space to the right. We are centered around the origin. So we're going to go 1, 2, 1, 2 is what we normally would do. We should be having an asymptote. We're going to be bumping it to the right because that's what our phase shift is. But let's make sure that we're okay with that our period is pi over 2, so half of it's on the right, half of it's on the left. And then this is, cut that in half, so it's pi over 8. That's negative pi over 8. And then we are going to shift pi over 2. Well, that's not pi over 2. That's half of pi over 2. So we'll have to shift all the way to there. So that point will shift 4 spots to the right. This point will shift 1, 2, 3, 4 spots to the right, and that will shift 1, 2, 3, 4 spots to the right. So that's 1/8, 2/8, 3/8, 4/8, 5/8, and 6/8. Okay, so the asymptote we would have had here goes 1, 2, 3, 4 to the right. This asymptote we would have had here goes 1, 2, 3, 4 to the right. Which is weird because that's where this one was. So here's where the unique part comes. Let's graph our one full cycle. We have a vertical stretch of 2. And we have our center. So that point would have went 1, 2, 3, 4 spots to the right. This point's up here. This point's down here. And you have your one full cycle. But uniquely, that your shift was exactly the same as your period. So if you kept on doing these one full cycles, it would be as if no shift had even occurred at all. Because that's what your normal graph would look like without any kind of a phase shift, which is just a different period, basically. So, technically, if you're graphing this and you notice that that phase shift matches your period, you technically don't have any kind of a shift going on at all, because this thing is cyclical. Every single pi over 2, you're going to get the exact same look. So that was just kind of a special case. It doesn't show up very often, but it does. And so maybe there can save a little bit of time. So that was graphing tangents and cotangents, part 2.